Hey guys, this is Mike. In this video, we're going to send data over the serial port from the Arduino to the PC. And we're going to do this in two different ways. The first way we're going to send data is we're going to make it really easy for us humans to read it. And then the second way, we're going to send it in a way that's friendly for the computer to read it, which is what we want in the final outcome of our challenge. We want to send data from the Arduino, like sensor values and things like that, and the simulation is going to interpret that data and make it easy for us to read. So we'll get into that a little bit later. To start with, I've opened up the Arduino IDE, and let's go ahead and start the first program. So the first thing I'm going to do is save this file, this blank file. And I'm going to save it as serial test 1, which you guys can't see. So save it as serial test 1, save. So my file's saved. The first two things we always write in Arduino, in any Arduino program, is void setup and void loop. You guys are going to see me do this a lot. I always hit this check mark after I've typed something. It's just a habit. I think it's a good habit to get into. So everything compiled, so this is a good program thus far. So next we're going to set up the serial port to be able to send and receive data. To do that, we type in serial with a capital S, .begin, and then in these parentheses, between these two parentheses, we type in the speed at which our Arduino is going to send data at, or actually what it's going to send and receive at. I'm going to use 57600, and this speed is called the baud rate. And these baud rates are actually kind of standard. You can't just type any number in here. I believe the default is 9600, but our robot platform, our challenge platform, the Rover 5 platform that we're going to use, is talking at 57600 by default. So we might as well get used to using it. So there's our serial port set up. So in the loop, now I'm going to send some data that we can read in the serial monitor. So to do that, I'm going to use two different commands. There's actually three commands we can use, but the third one is not really useful for sending plain text. It's more useful for sending data in a computer-friendly format, which is what the second way we're going to send data is. So I'm just going to do the first two. The first one is serial.print. And in serial.print, you can put in a number here, 1, 2, 3. You can put in a variable name, so if I had an integer, I would type in the name, say my integer is called x. You can type in floating point numbers, 3.14. I'm going to type in a string, and a string's in quotes. And I'm just going to send hello world. Actually, in this one, I'm just going to send hello and a space. And you'll see why I put the space here in a second. The second command you can use to send data is serial.print line. And that's what this ln stands for. That stands for line. And I'm going to send another string. And this time I'm going to send world exclamation. And what's different between these two commands is that this first one sends, here, I'll write what it will send in a comment here. This first one sends hello and a space. This second one sends world exclamation, but since it's print line, what it does is it makes a new line. So whatever I tell it to send after this is going to be on a different line. So if I was to serial.print line again and 1, 2, 3, or actually just the number 1, 2, 3, that would print here. And then whatever I print next would be on this next line. If I just make this print, this 1, 2, 3 is going to go right next to my hello world. Which, I don't know, that doesn't look very good to me, so I'm just going to print out print line. And now it's down here again. And this is going to be sent really, really fast, like multiple times, right? Because it's in the loop. So I'm going to put a delay in here just so it doesn't flood my screen. Let's say twice a second, so 500 milliseconds. And this looks good, so let's make sure it compiles, which it does. Good. So now I'm going to upload this. Done uploading. Okay. Open up the serial monitor. You'll notice I'm getting a bunch of garbage here. Now, the problem is that the Arduino is talking at 57,600 and the computer is receiving at 9,600. So this really isn't what the Arduino is saying. It's just saying it so fast that our computer doesn't know what it's actually saying. So we switch this to 57,600. There we go. Hello world, 1, 2, 3. Hello world, 1, 2, 3. And it's just going to keep on sending this. So that's the first way to send data. So I'm going to go ahead and save this again. And I'm going to, so that was saving serial test 1. Now I'm going to save as and create a new file called serial test 2. And in serial test 2, we're going to send the computer-friendly way of sending data. And the first thing I'm going to do is create a sensor, or connect a sensor to my Arduino. And I'm going to connect that sensor on analog port 0. And as we always do with analog, or with any pin, I'm going to set my analog pin up as an input. So pin mode, A0, input. I'm just going to delete everything in my loop. So I'm going to read my data into an integer. So integer, x isn't a very good variable name. Let's say sensor value is equal to analog read, since we're reading from an analog pin. And we'll give it A0. Okay, so that's our sensor value. So we're reading a sensor value. And right now I have no sensor connected, but if I was to connect a sensor, we would get actual sensor data. In the serial monitor, we'll probably just see a bunch of random numbers, which is fine for now. But any sensor you set up here, right, we're going to read it into a variable, which is the point of this. And once it's in this variable, to send it across the serial port, we're going to use serial.write. And now I'm going to write something that's going to look funny, unless you've taken programming before and know about what pointers are. But it's not really important that you know what pointers are right now, or exactly what I'm doing, as long as you can see it, write it down, and copy it later. We'll explain it a little bit later, but right now we're just going to use it. So what this says right here, this says, give me the memory location of sensor value, which is a variable in our memory. So this is the memory location of sensor value. Now on a Arduino, an integer value is 2 bytes. That's how big it is. It's 2 bytes in memory. So what serial.write does is you give it a memory location, and then you give it the number of bytes to send. So this says, give me the memory location of sensor value, which is where it is in memory, and then read 2 bytes from that memory location. So this is going to send whatever our sensor value is in a computer-friendly way that's going to read on the other side, on the PC side. And what's different about this serial.write, what we're doing here, and serial.print. So let's say I did serial.print, and say I printed out, let's say my integer was 1023, right? The difference between that and this write is that when I send this over the serial port, I'm going to get 4 bytes. I'm going to get the byte containing the ASCII value 1, another byte containing the ASCII value 0, another byte containing the ASCII value 2, and then finally another one containing 3. Now these values are not 1, 0, 2, and 3. Instead, they're an ASCII value, which is going to be, I don't know, I don't know my ASCII very well. It's probably in the 50s somewhere, 60s maybe. So this is going to be like, I don't know, maybe this is 48, or maybe this is 48. This is 49, 50, 51. I don't know. I'm not sure what my ASCII values are right now. But the point is that we're going to have to do some math and subtract some numbers from here and then multiply by the place it's in. So if it's a 1 and it's in the 4th place, that's 1,000. So you multiply whatever this number is times 1,000 to get it. It's really complicated. And the computer, I mean, to use it, we just don't want to do that. Instead, with this serial.write, we're only sending 2 bytes. In this case, since it's 1020, if our value was 1024, it would look like this. Let's see, 02FF, I believe. So if you haven't seen hex before, this is another way of representing a number. It's in base 16 instead of base 10. And it's not really important that you understand this, but this is 2 bytes here. This is the byte 02, which is just 2. And this is the byte FF, which stands for 255. Or I'm sorry, this byte is shifted over here, so it really doesn't mean 2. But in any case, these added together in binary right here is 1024. But these are 2 bytes that we can just put into the memory location of our integer on the PC side, and we get the same number. And it's a lot easier for the computer to do, right? I mean, we don't have to do a bunch of minuses and multiplications here. We just put this in memory and it's there. So let's go ahead and compile and upload this. And open up Serial Monitor again. And as you can see, it's a bunch of random letters, which we can't really help right now. So that's the end of this video. If you have any questions, I'll see you in class.